So today I have my colleague Vivek. So maybe I will start with myself first. So my name is Sebastien NG. I'm the National Sales Manager at Fronius, and today I have my colleague Vivek. I will leave him maybe introduce himself. Basically, we're in the same room, but I will let him introduce himself.
Yeah, thanks, Seb. Hi, everyone. Thanks for joining in. My name is Vivek. I'm an application engineer here with Fronius, and I look after our customers in Victoria and Tasmania. And yeah, we've got an exciting session for everyone. So yeah, look forward for who all can join in today.
But perfect, Vivek. So if you're in Victoria, make sure that you give Vivek a call. Any feedback you have, always good to touch base there. So we'll start in a few minutes. As you guys know, we always start a few minutes later. I can see some familiar names joining us there here. That's very interesting. So yeah, we'll start in a few minutes. Just to check that all of you can also see my screen here. Just maybe another round of raising the hands. If you can see my screen. Yeah, wow, super fast. That's great. All right, maybe we'll get the ball rolling there. So today we will talk about the optimization part 2. So just a bit of a reminder of the webinar series that we are doing this year. So as mentioned before, so all of you guys who have attended before, you know that this is a more an interactive type of webinar that we're trying to do. So throughout the session, we will ask you to unmute yourself if you want to participate. There's always good freebies that you can win. There are jackets, there are different tools. I just heard that marketing has a few new products, which I think you guys will like a lot. So please feel free to participate in this session. So today, what we're going to talk about is optimization, right? And we're also having some question. Okay, someone is getting a bit seasick because my screen is moving. Just give me 1 sec. I will just make sure that it doesn't move too much on my side. Just because we wanted to do something a bit more like a, how do we call this, like a podcast in a way, where we try to make it comfortable, but maybe that's something that we need to take into account next time. But thanks for the feedback. I will try not to move too much on my side. If you have any question, please feel free to pop it in the question section. We'll take it at the end, but as I mentioned, we'll try to make it more interactive throughout the session. All right. So optimization and what we have ready for all of you today, right? So just give me 1 sec. Optimization, what we will discuss is how to design a system, right? How to install the inverters and what we recommend. A lot of feedback that we get from our side, for example, when it comes to installing the inverters, they ask, is it okay to install it on this different surface? What is the best practice, right? So that's what we will cover today, but also looking at how can you effectively do a design. So maybe let's jump and try to get someone online, right? So here you can see a site, right? We want to install a 5 kilowatt inverter, maybe around, and then having around 6.6 kilowatt connected to it, right? Maybe if one of you guys want to unmute yourself, so what I would say is maybe raise your hand, right? Whoever wants to come online, and remember, whoever joins our webinar, joins this Q&A section or this questions time or spending time with us online, there are freebies available for you. So if any of you wants to maybe join the chat here with us. So let's bring someone online, right? So that's where we were before. Anyone wants to maybe join? So I can see two hands up. There is Danny. So maybe let's go with Danny here. So I will basically unmute you, Danny. Just give me 1 sec. All right. So right now you should have an option to just unmute yourself, Danny, if you can try it out.
Hey, mate, you got me, buddy?
Yeah, can you hear me?
Yeah, mate, how's things?
Good. How are you, Danny?
Yeah, good, thank you.
Where are you joining us from today?
Canterbury, New Zealand.
New Zealand. Wow, we are having more and more people from New Zealand. That's good to hear. Do you come to the Fronius webinar a bit? I see that your name is a bit familiar.
What's that? Sorry, buddy.
Do you attend our webinars a bit?
Yeah, I've attended the. This is the third one that I've attended, but sort of getting into the solar a bit more. Joined up with a company that does quite a bit of it, so just trying to improve my knowledge. So the more training and webinars I can get, obviously the better it is for all of us.
That's perfect. That's perfect. So you've been designing a bit, Danny, on your side. Have you done a few jobs at your where you're currently working?
Yeah, mate, I've designed the smaller systems. As I say, I've only been doing it for a little while. But yeah, the bigger commercial and more agricultural systems, I'm leaving with the guys in the office. So yeah, I'm just dipping my toes at the moment, but keen to get into it.
Yeah, awesome. So maybe a quick question, Danny. If you look at this picture, I know it's not the best resolution that we have there. Definitely something we work on this side. So you can see my cursor here showing the north roof, and you have east west. If you had to design a system, right, and you had 15 panels to put, what would be your configuration if it was basically up to you to decide?
So you're on the north face now, are you, mate?
Yeah. So this is north face.
Yep, sure.
This is east. This is west.
Yeah, I mean, obviously it'd be nice to get to pinch a bit of that west, but that tree's going to be a bit of a pain in the butt. So you're probably looking more of a northeast. So yeah, picking up a bit of that morning sun during the east and as much as we can on that north side, depending on how that shading's going from that house in front of it too, I guess.
Well, you mentioned shading, right? So if I go to the next part, that was basically two design proposed, right? So if you look at the option at the top here, they want to put Tigers as an example. And if you look at the bottom there, they want to use, basically what they did is shift the panels a bit. Which one would you pick between those two?
At this stage of my knowledge, I'd probably be picking the bottom one. Yeah, unless you're going to run some sort of optimizer system on those other two, if you definitely ran out of room. But if you can obviously shuffle those panels to the west side a bit more and prevent that shading from that chimney, then absolutely do that.
Okay, that's very interesting. Thanks so much for participating here. So you are going basically with the bottom option. So we'll go through this basically one, and then we'll cover a bit of the topic. So Danny will send you one of our latest Fronius jacket. So stay tuned. There will be more questions, but thanks again for joining us today. Yeah.
Thanks, buddy. Appreciate it.
Awesome. So as mentioned, looking at the whole site there, right, you have basically two options. So one of the, when the designer came in saying, okay, those are the proposed solution, we did actually have a look closer how we can optimize it, right? So looking at the bottom part, what we did is basically shift the panels a bit because there was a bit of shading there. And then from there, move one panel also to the eastern roof, right? So on our side, what we recommend, you're an installer, you're quickly looking at the site, right? This site example, you have a Primo 5, you know what panel you want to use. What you do next is just jump on the Solar Configurator, right? Of course, we are changing to our Solar.Creator. This is where you can do, let's say, a bit more in details and provide a quote, but we'll just look at the Solar Configurator quickly. So this particular customer, he wanted to have some power modules with this particular models of panel and use a Primo 5, right? What I usually recommend when it comes to designing is to increase the minimum temperature if you're in Australia from -10 to 10, right? And then go 150% so that you know all the particular possibilities in terms of design that you can have, right? And of course, we found his system, the one that he wanted to go. So it's 1 × 10, 1 × 5. But look at the different configuration, which allows you to do on the Fronius inverter. You can do a minimum of 3 panels if you want, right? So it gives you a lot of flexibility. right, in terms of the design there. Well, then it comes the installation of the inverter. That's where we have a lot of questions. And also remember that we have a repair center here in Australia. We get a lot of, let's say, inverters back, and we know, for example, what goes wrong sometimes. So the first thing is make sure you install the inverter on the wall bracket. I'm not sure if you can see here, there's like a small feature, right, which basically let the water go away. So if it is at the wrong angle, you can have like water just staying on top of here, right? So you can see also from this view, you have this feature which allows the water to go out, right? So this part where you have an integrated DC isolator, it's completely IP rated. So there shouldn't be anything coming here, right? So that's why we highly recommend that you install it on a flat surface, right? Then the next part, you can see there are holes there, designated holes. Please use those designated holes. What we've seen in the past is people drill through the plate, and what happens is it becomes a bit wobbly because basically we're not using the right holes, and then they can void the IP rating. Because remember, if this is wobbled a bit, right, the inverter may not close completely and have the IP rating that it should. So that's one important part. The next part, when you come with your conduit, make sure you have those rubber sealed properly installed, and make sure it is at the right angle. We've seen that also from picture of the site. I can tell you just small things like that will make sure that everything is nice and tight, right? So make sure that your AC and DC conduit is properly tight. And one thing, again, which we get feedback on is when you have your conduit there, I usually recommend put a bit of silicone sometimes. Why to put a bit of silicones there? Basically to make sure that, remember, if there's nothing on top or inside there, then there is a possibility that, let's say you have an entry from your switchboard to the inverter, right? Because basically there's like air circulating there, right? So just something to be aware of. Usually you have those rubber seal, right? And then you put the cable through it, but I know sometimes installers don't use this part, right? So just something to be aware of, yeah. And of course, having a drip loop is always good. You never know, someone is pulling the inverter. Make sure you do your test on the isolator before putting the inverter on. So we always ask to do an isolation resistance test. And I always say, some installers say, what is an isolation resistance test? So basically have a megameter with you and do the resistance test. So again, we have information which we can share about this. Also, you have this support cable. There's a reason why it's there, so please make sure that this is nice and tight there, right? Then, of course, you have the wall bracket on the wall. The remaining part is having the inverter. So make sure that the isolator is on the off position. Don't try to force. Anything that you force in means that maybe something is not properly set, right? So put the inverter on the wall bracket, snap it in. Make sure you have those two screws nice and tight. I've been to sites before where this was not properly screwed, where the inverter just came out of the wall, right? So make sure it is nice and tight, or else it's basically voiding the IP rating. And also you have data communication gland there that you can use, right? And then from there, put the bottom plate, the bottom we call it a .com cover. Put the .com cover back on, make sure it's nice and tight. And there's a lot of installers who give this feedback. Sometimes we're not sure. Always put the top in first, and then it will click into place, right? So again, pretty straightforward installation there. Now, when we look at this particular side, right, we were looking, okay, there was a bit of shading. I'm not going to go on the west side because there's a bit of shading. You never know, right? A tree may appear out of nowhere, and that's what we covered previously in the previous presentation. What happened if suddenly a tree appears, or if you have shading on a side? So we should actually look into what happened to a string inverter when you have shading, right? So this is an example. You have string inverter, you have multiple strings in parallel. The information which is out there is that if you shade one panel, all the whole string where this panel is will go down, right? Because it's basically someone kind of blocking, or the panel is blocking the current, like a king in the hose in a way, right? So the thing is, panel has evolved with time, and most panels, if not all panels nowadays, have bypass diode, and most of them will have free bypass diode in the panels, right? And how does it actually work? So here you can see that there are 5 panels in series, right? And you can see that the other panels, the 4 panels on the right, even if you have a bit of shading on it, it will go to 100%. The panel which is getting shaded, here you can see it will bypass this strings of cells, which gets affected by this leaf, for example, and will allow the current to go through. And that's where this panel will still get the power from those 2 strings of cell, right? Of course, when you combine that with a smart algorithm inside the inverter, which is the dynamic peak manager, what we are actually doing is we're tracking the whole curve, right? The PV curve. So here you can see voltage and PV output, right? When you have shading, the curve may look like the red one or the black one, right? And when you do the tracking, so for example, a normal tracker will track, find this point, and then say, hey, power is reducing, go back to this point. That's good when you have 1 peak. But if you have 2 peaks, you can say that, okay, the normal tracker will track, find this point, oh, power is reducing, go back to here. But it won't find this over global maximum power point. So what is happening if you look at the whole picture? Of course, you have a bit of shading happening on the panel, right? Then you have the bypass diode kicking in with the combination of dynamic peak manager, our basically shading management. That's how we can optimize, let's say, the whole system and not having a lot of losses as what we shown in the first picture, where, for example, 1 shaded panel will bring the whole string down. That's how we don't lose the whole string. You lose only these particular strings of cell. So it's only 1/3 which is lost there. Well, there's a lot of studies out there if you're interested. So here you can see where you have, let's say, a system, right? Identical system, one with a string, one with MLP. So what is MLP? It's module level power electronics, like optimizer or microinverters as an example, where there was testing done, right? And what is very interesting on this study, they did basically string inverter versus string and optimizer like Tigers, for example, and also just optimizers, right? And the result of this study was very interesting, because when there was shading, the actual string inverter with this pole, as you can see in the picture before, moving the moving shadow over the panels, the string inverter actually perform better by 2% compared to the MLP system, right? So that's where you get more yield with a string inverter when you have this partial shading, this shading moving across the panel. Now, if you look, for example, without shading, right, you can see that the string inverter do 1.5% also more yield. As you can see that in certain months, the MLP perform better, but if you look on the average, that's how you see that the string inverter also, again, outperform or perform better than the MLP system. So as you can see, there's a lot of data out there which basically shows you that even a string inverter with the right smarts into it, with the smart tracking algorithm, can deal with shading. I highly encourage, if there's installers also joining us today, is when you go on a site or you're finishing a job, just try to put a piece of cardboard on a string and see what the inverter, the string inverter, the Fronius string inverter is doing, just so that you get also a bit of information. There's also a lot of videos, I would say, out there which shows this particular different testing around Australia, which I highly encourage people to have a look. So what I would basically do here, is there anyone who wants to have a chat about shading, or for example, this information is new? Anyone wants to maybe raise their hand, have some comments, want to to discuss this shading topic with us. All right, there's someone who wants to, I think Robert, you want to join in. So maybe what I would do is I will unmute you. So maybe you can unmute your mic now. Can you hear me, Robert? Here we go. All right, so we have Robert joining us. How is it going on your side?
Mate, going well here in Queensland.
It's rain. Is it still raining there?
Sunny. We actually got an install in today, believe it or not.
Oh wow! I hope they had all the umbrellas on the roof, or is the weather a bit better? What's that?
Yeah, they all stood there on the roof with their umbrellas, just waiting for it to rain.
I hope things gets better. We are looking at New South Wales, also not looking too good. But definitely that's good to hear. So Robert, what did you think about the whole shading scenario with a string inverter versus let's say an MLP or optimizer, as how we call them?
I think it's brilliant. I suppose the challenge is we've got to look at what CEC requirements are and work within those, but just for light shading, I guess, and people who have concerns where we'd normally go in with optimizers, it's something that we can just say, well, hey, it's only a little bit of shading, the panels can take care of it, and the inverter's going to compensate for the shading issues, which you explained it very well, and I think it's something I've got to work on to now explain it to my customers.
And what will help you to basically explain to your customers there, would you think?
Probably something that's a bit simpler than this, maybe a little YouTube video or something very simple with a cartoon that would explain it with a happy voice.
Okay, not my voice, right?
Well, I mean, this is technical conversation, and most customers, if they were watching what we're doing here, they would have gone and watched, what's that? Married at First Sight or something. I don't know. That's the sort of mentality we're dealing with over there. So, they don't like the technical stuff too much, but they do want to know that, hey, if there's a tree over there, well, guess what? Our system can take care of it, and you don't need to spend extra money on technology to try and compensate for it.
Yeah, perfect. So, any points you want to share also with us? Anything else you want to share with us, Robert? Because
I liked the diode explanation on the panels. That was really good. I hadn't seen anything like that before. That's good.
Perfect. Well, Robert, thanks so much for joining us. I just make sure that I have all your contact details quickly here. We'll send you one of those freebies there. I'll try to get you the new jacket as mentioned before. Marketing will hate me with just giving jackets always out, but for you for sure. So we'll be in touch, right? And thanks so much for joining our webinar today.
Thanks, mate.
Awesome. So as you can see, definitely trying to help with different information. It's something which is very simple to the end user, is going to be also helpful. But thanks for sharing your experience there. Right. So moving to the next part, optimization also has another section, which is basically making the most of your energy, right? Which I will then pass on to my colleague Vivek to talk a bit about.
Okay, so thanks, Seb. Interesting session on shading there. Always an interesting topic. So we have been talking about optimizing energy. Where this can help you is this can help your end customer is increasing increasing the value of their self-consumption. That is decreasing the dependency on the grid and using the energy that is produced at the source and using it efficiently. As a lot of you would be aware or would know that with our snap inverter series, we could control up to 4 loads basically based on your PV surplus or your PV production. Your surplus being the extra energy that is available after all your household loads have been fed. That's the similar concept with Gen 24 as well. So how this works is the smart meter here measures the amount of power that is being fed to the grid or drawn from the grid. So if you have any extra power available after everything's been used in the house, you can divert that power to one of the loads of your choosing. So once the smart meter measures that you have an extra power feeding into the grid, the inverter will send a signal to turn this relay on, which will supply power to this load that you have. This energy optimization can also be achieved with our solutions such as the Ohmpilot and the Wattpilot, which has been discussed in our previous webinars. To set this energy consumption or your load management, how you can do that is in the inverter's web UI, you can go to the load management tab there, and under load management, you can select options and you can set rules basically for each of the loads that you want to turn on based on the power that's available. For example, if you have 4 loads there, you can name them individually. For example, you've got pool pump here. Now, if you want to set this load up by power surplus, that is depending on the extra power that you have, you will select controlling by power surplus, and then you will set the thresholds. So these thresholds are the values at which your load will actually turn on or turn off. So for example, if you have a pool pump that is rated at 1000 watts, you can set the value to turn on at feed in 1200 watts. So you give yourself a buffer of about 200 watts in case of any changes in the grid value. So anytime the feed into the grid goes over this 1200 watt value, your load will turn on. Now, to turn the load off, you can either set it as feed in. So turn the load off when I'm feeding maybe say 200 watts, or you can set it as consumption, that turn the load off as soon as I start drawing power from the grid. In this case, the value to turn off is set as 0 watts. So if you draw even 1 watt of power from the grid when this load is on, the inverter will turn this load off. In terms of duration, what this basically means is how long your load will stay on. So you've got two values here. You've got minimum duration and you've got maximum duration. Minimum duration will mean for you, so whenever the load turns on, it stays on for this value. This prevents switching on and off of the load, and it can help with the lifetime of that load. For example, if it's a cloudy day and you're getting various levels of irradiation throughout the day and your power levels are not fixed, when the load turns on because of your threshold is reached, it will stay on for 15 minutes. Even if this threshold values goes below this value, the load will still remain on for 15 minutes, and as it will stay on throughout the day for this maximum duration. For example, with the pool pumps, you would generally want it on for about 8 hours in a day. So once it turns on, it will make sure that it after this 8 hours value has been reached, it does not turn the load again after that, after once this maximum duration has been reached. For example, if your pool pump has already been on for 8 hours in a day by maybe 4 p.m., even though excess power is available after that, it will not turn that load on. Now, there's also a value called desired duration when you're setting this up. So what this means is, by a set time of the day, your load will always remain on for this set duration. For example, in this case, if your pool pump, here the duration is set as 4 hours or 240 minutes. So your pool pump should be on for 4 hours by 6 p.m. Any day if your pool pump has been, for example, say on for 2 hours by in a day and it's 4 p.m., the load will turn on so that by 6 p.m. it meets this condition of having the load on for 4 hours. So this is your energy management side of things and how you can optimize self-consumption for your end customer. On the other side of things, we have some solutions where you can also optimize your servicing side of things. In service, how your general service process looks like is you get to know what the fault is. Maybe the customer tells you, or SolarWeb, you get a notification what the fault is. You go to site, try to diagnose the cause of the fault, and once you've found it, you fix it, and then you contact tech support if the inverter is still not running, and organize an inverter replacement with us. So from there, tech support confirms that you can get a replacement inverter from us, wherein you go to the site again to replace the inverter, and then the case is finalized. To optimize this process for you, we have developed an FSP service process. In this service process, you diagnose the fault at your end, and on site, when you're trying to diagnose the cause of the fault, you replace the board on site without having to replace the whole inverter, and within one site visit, you can achieve the case is resolved for you. So this can help you save a lot of time. Plus the reimbursement is more with the FSP service process or the Fronius Solutions Partner Service process. And this process can also be further streamlined if you use our SOS platform. So with our SOS platform, you can begin troubleshooting. So anytime you have a fault, you can go on SOS and you can enter the error code, and it will give you step by step how you can resolve this issue on site. If after following all the steps the issue is not resolved, then via the SOS app you can organize a hardware replacement with us. So if you are an FSP, you can organize a board replacement with us. If you're an installer who is currently not an FSP, you can organize inverter replacements with us. Think of this as a self-service tool wherein you do all the things at your end, and the case is raised within tech support. And the turnaround period for SOS cases is very fast as well. So we provide you fast resolution when you raise cases via SOS, and this saves you time in case the lines are busy because other installers are also waiting on the line. So this is how you can optimize energy management for your end customers, and this is how Fronius optimizes service process for installers as well. And now I'm going to pass it back to Seb to talk about what we are covering in the next webinar. Thanks all.
Thanks. Again, there shouldn't be an echo now, so let's, yeah. Thanks, Vivek, for the explanation there. So as Vivek mentioned, the FSP or Fronius Solution Partner is when you're trained by Fronius to basically change the boards and the components. There's again more additional benefit. We'll do I would say proper training for that. But basically, yeah, that's one of the additional benefits that you have. And this app, just to make it also, because we always share this, for us, it's not a tool to replace tech support as an example. It's a tool to help tech support, because you never know. I remember when I started, there was like only 3 people in tech support. Now we have 9, but you never know if everyone just call at the same time. We want to make sure that with the premium product, you have a premium service, and that's why we have another option where we can basically speed up the process if ever our tech support is too busy, right? So that's why we have everything in place to help you. So just before we move on to some question, I want just to cover a few of the points for the next webinar. So what we're going to talk about is about reliability, about what makes Fronius inverters very unique, what made the Fronius inverter popular in Australia, right? Why active cooling is important. I know this is a big topic, and a lot of you guys always mention that. And then talk reliability to its core, right? What are we doing a bit different out there, and what is our vision? And every webinar that you come and basically participate as what we have today, which is a bit of a different setup, right, than previously done. You can also win some freebies, which we will send to New Zealand now, and to also in Queensland, in Queensland, in Australia. Funny enough, throughout the last few webinars that we've done, there's always one person from New Zealand and one person from Australia winning it, and we actually didn't really know exactly the location, but we want to really thank you guys for joining. So maybe let's jump into the into the question section here. So the first question, which was pretty good, was, can you do load management on both the Gen 24 and Snap inverter? So yes, it can be done on both the Gen 24 and Snap. Just make sure when you have the Snap inverter, there's the monitoring card inside, which I would say most units will have. It's usually some of the commercial. The light version, they don't have this card. The next one, has Fronius designed a Bluetooth setup for the city clamp when the system is on the shed and meter box is on the house, but they want a battery? All right. When you have a battery system, it's a bit of a different solution. We don't have a Bluetooth option at the moment. So usually what you will need to do is hardwired basically the meter. It's not the CDs, but the meter there. You need to hardwire it to the inverter, right? So just going back to the question before, when you have basically this I285 to Wi-Fi converter in the mix, when you have a battery system, you want to have the response to be a bit faster. But that's where you can have a bit of delay with this I285. So that's why, for example, we don't encourage it. We haven't tested it ourselves. So if you want to give it a shot, it is, yeah, I wouldn't recommend it. I would recommend always to have it hardwired, especially when you have a system like that. With the inverter and battery, usually I would say to be having the battery close to the house is usually the option. But yeah, again, it depends on the site as mentioned. Because maybe because we're having just can't really see question there. Maybe if you want to post your question in the chat function, if you guys don't mind there, we can see it again because we can't see the question at the moment. Apologies for this. Looks like GoToWebinar, we're having some challenges with the software today. But if you want to maybe type some of your question to us, we can have a look just in the chat section, not the question section, the chat section. All right. So looks like I think there's few questions that was left in the question tab. Apologies again for this. So what we'll do is we will reply to each of you who send the questions there. So again, as discussed before, there will be the next webinar, which we will talk about reliability and what is very unique about Fronius. And again, we would like to thank everyone for joining the webinar. As you can see, it's a bit of a different setup. We are trying getting you guys to join and having a chat with us. So thanks so much for joining today. And we also want to make it nice and short, but just from the Fronius office here, thanks again, everyone, for joining the webinar.